This is a movie recommendation system, and today I'm going to build it using machine learning. That means real movie data, a clean user interface, and a solid model. By the end of this video, I'll type a movie like Interstellar, press enter, and my app will instantly recommend movies with similar vibes. And yes, you can build it too. To make this work, I decided to split this project into two parts: a backend script that builds the brain of the AI and a front-end app that we actually interact with. So let's start by building the brain. First, I created a file called model builder, the load and filter movies function. I'm using the MovieLens dataset, which contains thousands of real movies and user ratings. But here's the thing: if we include every obscure indie student film that exactly one person rated, our recommendation will be garbage. So this function merges the movies with their average ratings and ruthlessly cuts anything that has less than 10 reviews. Clean data is happy data. Next, we need a way to describe these movies. Enter process genome tags function. Users on the internet have tagged these movies with thousands of keywords. This function takes a massive file of tag relevance scores, filters out the weak ones, keeping only scores above 0.5, and then squashes all those tags together into one giant space separated strings for movie. So a sci-fi movie suddenly has hidden text profiles reading space, aliens, futures, survival, astrophysics. Step 3 is compile movie features. We take the title, the official genre, and those awesome genome tags we just processed and mash them all into a single column called combined features. We are basically creating a bag of words for every single movie in existence. But here's where we hit a wall. How does the computer actually read this bag of words? At first I thought easy, just count how many words two movies have in common. Then I realized that if I do that, every movie becomes similar because they all contain words like the, movie, and is. Very helpful. Truly a revolutionary machine learning language, but we don't need that right now. What we need is a way to make important words matter more than the boring words. That's exactly what the generate TF-IDF matrix does. It uses something called TF-IDF. Scary name, simple idea. If a word appears a lot in one movie but not in many other movies, it gets a massive score boost. Words like vampire, detective, or wizard become much more mathematically important than the word the, and so on. This function runs that math and turns every single movie's text into a huge vector of numbers. Finally, we tie the backend together with the build model function. It runs all those steps in order and then saves the final mathematical matrix into a cached pickle file. This means our app does not have to recalculate the entire universe of movies every time we refresh the page. Okay, enough with the backend theory. Let's build the actual UI for this. And to do that, we are going to create a new Python file called app.py. First, we are going to import all the necessary libraries for the UI itself. As you can see, this is a different one. This is where we are going to use model builder's main orchestration function, that is build model. I wanted this to look less like a school assignment and more like a real product. So using Streamlit, I built a minimal front end with a dark theme, center layout, rounded movie cards, and a clean search box. So this is just a UI and styling. When you type a movie and it triggers a function called get recommendation, remember those vectors of numbers we made? We aren't going to compare thousands of numbers manually. Instead, this function uses something called a cosine similarity. Another scary term, but that basically asks how similar are these two vectors. If the vectors for two movies point in almost the exact same direction, the movies are similar. If they point in completely different directions, they are not. And the beautiful part is that all of this terrifying vector calculus is handled by literally one line of Python. Now after this, let's add a dynamic movie poster using an API. After we fetch the poster, I also did myself a favor and cached all the data, so every time we run it, we don't hit the API key. Once it's run, it's saved in the local web storage. Next, we have load and prepare data as well. This will load our pickle file, which will be created by model builder, and then we can move on with the recommendations. And finally, I also added the extra Streamlit UI, and I'm going to give all of this code down below in the comments. If I do forget, please do remind me. Now let's run this app and see how it works. First off, like always, we're going to start with making a virtual environment. Next, we are going to activate the set virtual environment. Now we have a requirement.txt right here, which includes all the libraries we need. We're going to install those libraries. As you can see, it got downloaded after a long time. And to start this app, we need something different. Usually we would do Python app.py, but when we're using Streamlit, what we're going to do is Streamlit run app. And this is the user user UI, which will take a few minutes because we haven't trained our model yet, which is being trained right now. And let's search it up, and we ran into a problem. Name movies is not defined. So something happened here that is not working, probably an issue with our pickle files. So okay, the problem here is app.py. We created this, but we never loaded it. So we have to load it. Let's load it here. Since we loaded the app, let's rerun it. As you can see, type Interstellar and find movies. We got the Interstellar movies and all the posters as well, except the Arrival one. So now let's test other movies as well. Let's try some animated movie like a Toy Story. And as you can see, I got Toy Story 2, all the animated movies, we got it here. Now let's try a romance movie. Let's say The Notebook. We couldn't find The Notebook in our database. Usually when this happens is usually this. If we find the movie, the always goes behind the notebook. So we got all the romance movies as well. Now the question is, how does it know that these are similar when the plots are totally different? Because the model isn't understanding the story like a human. It's finding patterns in the word and genres that tend to appear together. As you can see in the Interstellar, what's happening here is the words like space, science fiction, mystery, future, survival, they all appear together. And when we look at the movies similar to that, this is what we find out. Now let's try to break it using movie that does not explicitly say it's a superhero movie, The Dark Knight. And if we search for it, as you can see, it's smart enough to know it's the Batman, The Dark Knight Returns. And we got other Batman movies as well as some other movie. And this is the part I love about machine learning. You take something messy and human like movies and turn it into numbers, and somehow genuinely useful behavior emerges. Now, to answer the $1,000,000 question, is this how Netflix recommends movies as well? Not exactly. They use much more advanced system, including collaborative filtering, deep learning, and billions of data points on user behavior. But the core idea is surprisingly similar. Represent items as vectors, compare them, and rank the closest matches. And there you have it, from movie descriptions to vectors, from vectors to cosine similarity, and from cosine similarity to a real working web app. If you enjoyed this video, subscribe. See you in the next one. Happy coding, keep coding.